All right, howdy, folks. Today we're going to be going over the area of a rhombus, right? Remember, plural, area of a rhombi. So this is your warm-up. Find the area of the rhombus shown below, right? Find the area of the rhombus shown below. You might be thinking, well, aren't you supposed to teach us how to find the area of this rhombus? But think back to what we did previously with quadrilaterals. What have we done already this unit that will help you find the area of this rhombus? All right, so take a minute to pause the video and try this problem on your own. All right, I'm assuming that you have paused the video, you've tried it out, and it's time to check your answers. So let's go ahead and push forward on it. Hopefully you would remember that a rhombus is a type of parallelogram, right? And we already have a formula for the area of a parallelogram. Call that for parallelograms, area is equal to base times height. So in this rhombus, we are given the base, 17. We're given the height, 11. Cool. That's it. We're done, right? So, well, not done entirely, but we have to plug it in. There's really nothing more to do besides multiply these two numbers. So let me get them in the right order. So we have the base and the height according to our formula. Base is 17, height is 11. But we're going to multiply those two things together, right, in our handy-dandy calculator. Let me just do a quick math here. So that's 170 plus 17, 187. Let's get the correct units. We're talking about area, so square meters. Right, the area is equal to 187 square meters. All right, also remember that in a rhombus, all four sides are congruent. Right, this side is congruent, that side is congruent, these two over here. And so if you were given a very similar diagram, but just a little different, if you were given a diagram like so, you should be able to still find the area of this rhombus, even though the height that we're using isn't perpendicular to the base that we were given, right? Because all of these sides are going to measure 17 meters. Right, so keep that in mind as you're going through these rhombus problems. Let's move ahead to this problem down here. We want to find the area of the rhombus below, where the diagonals measure 19 and 21 feet. Right, so not just one section, but the entire diagonal from C to D, or from C to D. We'll say that that's 19. This entire segment, this entire diagonal, it's gonna be 21. We're kind of getting in the way here of those diagonals, but we'll see something in a second that's going to make it easier for us to use these numbers and find the area. All right, so I'm going to hop over to another window. All right, let's take a look at this little rhombus right here. All right, so we got a rhombus ABDC, ABDC. Right, and something you have to remember about a rhombus is that the diagonals are perpendicular bisectors of each other. Right, so this red segment has been bisected, as well as this blue segment, and these two diagonals are perpendicular to each other. Right, as a result, because we have all of these right angles in the center, and because these two red halves are congruent and these two blue halves are congruent, we have congruent triangles all the way around this rhombus. Right, all four of these yellow right triangles are congruent. Right, and that's going to be important. Let's see why. So if we take all of these right triangles from the interior of the rhombus and we just rotate them, rotate that one, we'll rotate this one on the right and on the bottom. Right, we rotate all of these triangles to the exterior of the rhombus. So we're leaving behind these blue right triangles and moving the yellow ones outside. Right, and these hypotenae are congruent and flush with each other. The resulting shape that we get is a rectangle all the way around the rhombus. Right, we've got a rectangle outside of this rhombus. And that's going to hold no matter what size rhombus we have. It could be itty bitty teeny tiny, it could be super duper big. Whatever size rhombus we have, we can rotate these right triangles to the exterior and get a rectangle. All right, so let's pop back over to our note. We'll see how that helps out. Oh, come on now. There we go. All right, back to our notes. Let's see how that helps us out with our problem over here, this rhombus we're working on. All right, so I'm going to replicate this diagonal. Oh. Right, let's duplicate that. So I've got another version of this diagonal, and I am just going to translate it to the edge over here. Translate down here as well. All right, and because we said this diagonal had length 21, that means that this diagonal that just got translated has a length of 21, and this has a length of 21. Let's get the units as well. 21 feet. All right, we can do the next diagonal in, let's say, purple. And then I can duplicate that, pop it there. You can duplicate it again, translate over here. All right, remember this is going to be 19 feet. All right, and then let's replicate some of the shading in that diagram. All right, so we had yellow triangles in the exterior. I'll just go ahead and highlight all of those yellow. Then we had blue triangles in the interior. Right, now remember, because we knew that all of the blue triangles in the interior were congruent, and all we did was rotate them to the exterior, we've got 8 triangles here, all of which are congruent. But the rhombus that we want to measure the area of is made up of 4 of these triangles, and the rectangle, the thing, is of 8 of these. So ring that the area of the rhombus is equal to the rectangle. Formula for area of a rectangle, recall that that was base times height. All we need to find the area of the rhombus is the base and height of the rectangle. And that works out really nicely because you can see in the rectangle that the base and height of the rectangle came from the lengths of our 2 diagonals in the rhombus. So this is just a little matter of changing some words and making some substitutions. So the base would be 1 diagonal, and the height would be another. All right, for the sake of how we're going to format this formula for the area of a rhombus, I'll actually just show it to you right down here. We're going to use this formatting. The area is equal to the length of the first diagonal times the length of the second diagonal, all over 2. All right, that's going to bring us back to this problem. We want to find the area of that rhombus in blue. We know that the lengths of those diagonals were 19 and 21. Those 2 diagonals will get multiplied together and divided by 2. So into the calculator I go. 19 times 21 divided by 2. The area is equal to 199.5 feet. We're talking about area, so feet squared. All right, so the key takeaways that you need for today. Remember that a rhombus is a type of parallelogram, so you can be using this formula, area equals base times height, as appropriate if you're given the base and the height. If you're given some of the diagonals, you might want to use the other rhombus area formula. Area is equal to diagonal 1 times diagonal 2 over 2. And also remember, that you can use right triangles to determine lengths you need. There might be triples, there might be right triangle trig, there might be Pythagorean